Quadratic equations come into math whenever there is an exponential increase or an exponential decrease. Just look at this kid with the skates. Doesn't her velocity increase exponentially on the downward slope? And doesn't her velocity reduce exponentially on the upward slope, coming to a complete halt? So that is why whenever you see the equation of a quadratic equation, it will always be in the form of x square plus 4x plus 5. The square term itself indicates that you are dealing with an exponential increase or an exponential decrease of whatever you are plotting on the y-axis. Now I want you to look at this equation of football which is going and hitting the ground. You'll see the equation as y equals to minus x square plus 4x plus 5. Now if you write this equation equals to 0, all of a sudden it becomes a quadratic equation. So now when you find out the solutions to this equation, you will get one or two values of x. These two values indicate the possible values of x at which the ball will touch the ground. Now x means whatever you plot on the x-axis. In this case it is time. So the values of x that you get will be the possible times in seconds at which the ball will touch the ground. The value of y indicates the height. So y equals to 0 means at that time when the height is 0. When the height is 0, that is the time when the ball will touch the ground, and the value of x at that point when it touches the ground will be the time taken for the ball to touch the ground. So when you equate the entire quadratic equation to 0, it also means y equals to 0. So when you put minus x square plus 4x plus 5 equals to 0, are you noticing that y also becomes equals to 0? And are you getting that when y equals to 0, conversely, it means minus x square plus 4x plus 5 equals to 0? Now, a monomial means that there is only one x term raised to 2. Polynomial means there will be two x terms in decreasing order of their degrees. Now when a polynomial equals to 0, and notice that there are more than one x terms. Now when you get the solutions of these quadratic equations, for example x square plus 3x plus 2, the solutions are minus 2 and x equals to minus 2 and minus 1. These are the 2 points at which the roller coaster touches the water. Similarly, for x square plus 5x plus 6, the solutions are x equals to minus 3 and minus 2. That means minus 3 and minus 2 are the 2 points at which the roller coaster touches the surface of the water, once while going inside and once while coming outside. I hope this is clear. So the roots or the solutions of a quadratic equations are those points where whatever graph you are plotting, of that graph, whenever that graph touches the x-axis, those are the points where you find the solutions. So let's say the solution is minus 3 and minus 2. That means the graph touches the x-axis or the ground in this case at minus 3 and minus 2. If there is only one solution and the graph touches the ground or the x-axis at 0, that means there is only one solution. It just touches the ground and then moves away. It doesn't cut through the ground or cut through the water surface. It just slightly touches the surface of the ground. It doesn't cut through the ground. as you are seeing in this roller coaster. The roller coaster is just touching the ground and moving away. This means that it touches the ground maybe only at one point at x equals to 0. The entire article of this on this subject is written on analogyseeker.com, a website started by me, where you can ask analogies or examples for any topic, and somebody like me or myself would be answering the question, where you also can answer with analogies and examples of complex concepts of maths and physics for other people. What if there's an ebook where at least the building blocks of math can be visualized with the help of intuitive images like the way you're seeing on the screen? What if sine theta can be visualized as a measure of how perpendicular two forces or influences are? In other words, sine theta comes into math whenever two forces are such that they produce maximum impact when acting perpendicular to each other. What if you can visualize the actual reason of why sine theta equals to opposite side upon hypotenuse with the help of an animated example as you are seeing on a screen? Now, just as sine was a measure of how much perpendicular two forces are, what if you are told that cos is a measure of how much parallel two forces or influences are? Ever wondered why cos 0 is always maximum? The more aligned, the more parallel two forces are, the greater the value of cos theta. Cos, in fact, comes into math when two forces or influences are such that they produce maximum impact when acting parallel to each other. What if complex numbers can be visualized with the help of animations like you are seeing on the screen? I raised to 1, a rotation by 90 degrees. I raised to 2, a rotation by 180 degrees. I raised to 3, a rotation by 270 degrees. And I raised to 4, a full 360-degree rotation. What if someone tells you that complex numbers comes into math when one influence splits into two or more branches either due to rotation or some other reason? One branch is called as the real part, the other as the imaginary part. What if an ebook tells you that complex conjugates are nothing but vertically opposite mirror images of each other? 3 plus 4i is like climbing the uphill of a slope, and 3 minus 4i like going downhill. What if the formula of logarithms can be visualized as the log of every effect gives you the cause of that effect on the other end? The base of log is nothing but the rate at which the cause and effect relationship is changing. What if in integration or calculus, dx and dy means keep adding along the x and the y axis respectively? dr would mean keep adding along increasing radius, dh along increasing height, d theta along a vertically curved path, and d psi means keep adding along a horizontally curved path. What if integration and differentiation can be seen as evil twins of each other, that is, reverse processes of each other? Integration, a process of addition; differentiation, a process of subtraction or taking away. Divergence can be visualized as the rate of change of the field as you move away from the source of the field in a three-dimensional setup. Curl, on the other hand, can be seen as the ability of a field to try to rotate you or spin you in a certain direction. I, j, and k
being the three different planes of rotation, three different dimensions in which rotation can take place. What if you are told that the diagonal of a matrix is the axis around which things rotate, and that the transpose of a matrix is the entire matrix or the object that it represents rotated by 180 degree about the diagonal as an axis, and that the transpose of a matrix will be the entire matrix rotated by 360 degrees. Visualizing Math 1 is the result of years of hard work done into the research of the meaning behind these equations. What these equations mean are explained with the help of simple and down-to-earth examples, animations, and analogies, so that everyone can understand. Everyone is a beginner at some point, and Visualizing Math is dedicated to beginners, or even advanced users who wish to visualize things in order to understand. It has very little definitions and more of examples and analogies. The link to the ebook is given in the description. It is also available on Amazon as a paperback, the link to which is once again given in the description.